Good evening, 2021ers. This is Professor Kaufman, and this video will serve as a short walkthrough for Lab 1. I plan to reveal most of the answers to the lab, so those of you who are struggling either with the technology or the specific answers involved should get a leg up by watching through this. For those of you who already completed the lab, you might learn a few new tricks along the line if you choose to watch through. I'd suggest perhaps scanning through quickly, playing it at a faster speed, or maybe jumping around a little bit. I'm going to switch over at this point to a screen view so you can see what I'm on about. And over here, I'll start with Canvas. You'll find most of the course materials by clicking through starting on Canvas, although there'll be some static web pages that you can bookmark if you're so inclined. The primary link that most of you will click on in most cases is this course schedule and materials, which shows up on top. Should open a new browser tab over here. And you can see listed on it are locations where you can find the lecture materials, code downloads, etc. And then also the homework and lab materials over here. Since we'll be working on Lab 1, you'd want to click on the setup, and I'm going to click to open that in a new tab over here. And the format for this, along with homeworks and projects, will follow a very similar convention. That there'll be some introductory material up towards the top. Down below, a manifest listing the files that'll be part of the code pack as you download it. Some potential other information, and then a copy of the questions.txt file, which is part of each of the labs. This contains instructions about what to do during the lab, and I'll whiz through parts of it, but it generally comprises two sections. There'll be some quiz questions here, and within the text file itself, you'll want to fill in an X to mark the multiple choice answer that you think is most appropriate. And then later on, there's also a code section that shows up a little bit lower down here. In this case, we'll be modifying a program called helloc.c. This being the first lab, this is primarily designed to introduce you to some of the infrastructure mechanisms we'll be using throughout the course. So there are a bunch of little details to sort of learn, but know that this will pay dividends because in the long run, these are what we'll be using for the next 14 weeks at a stretch. One of the most important things to mention is that the code that's listed over here, it comes from a code pack that's usually linked right at the top. And so one thing I could do at this point is to click to download this Lab01 code.zip, and I'll be prompted to download something. I'm actually planning to work on this lab not on my own personal laptop, but instead on the CSCI Labs machines. And this is because in the event that you don't have a home Linux environment, as I'm running right now, you'll want to get access to it. And one of the easiest ways, we'll look at in just a moment, is to make use of the CSCI Labs machines through, for instance, a web browser tab, or possibly through a remote connection in an editor, like VS Code. I'll be demonstrating the former option, the remote connection through a web browser tab. So I'm going to defer the downloading until we actually get into that environment. The reading material that's associated with this is oftentimes listed up here, and there's a link here to the Accessing Unix and Linux Programming Environments tutorial that's part of the course reading. If you already set this up, that's cool. I'm going to click on it now and open it in a new tab, just to mention one handy feature. It's a rather long document that outlines a bunch of different methods that have their place in terms of accessing Unix environments. You don't need to know about all of them, but certainly the more you know, the better off you'll be if you find yourself in a new situation. The one we'll focus on is listed down here as part of the University of Minnesota computing resources. Now, all of you will have in-person meetings in labs and are free to use those should the lab classroom be available when you'd want to work on your lab. There are also some public labs, and you can always go in and sit down at those to work on material, and you'd log in physically at that spot and use the terminal that's before you. In the event that you're lazy like me and want to sit at home, another option is to remotely log into one of these using the FastX3 system that the lab administrators have set up. Now, this thing is a cool system that I wish I had had when I was an undergraduate because it's as easy to connect to a machine as clicking on one of the links that are down here. I'll make a note that there are 3 machines listed, for instance, for this Keller Hall 1250 lab, but there are actually 37 of them. So as I click here, this will take me to machine number 10, but I could also change the link URL to be machine 11. Let's try that just quick. I'm going to control click in order to open this in a new tab. And you can see over here I'm prompted for my University of Minnesota login information. So I'm just going to click here. Actually, I guess I have to punch it in because I haven't logged into this one in a while. Okay, and I think I'll get a duo prompt next for this. So I'll punch 1 because I prefer to get push notifications on Duo. See, my phone is lighting up, and so I'll jump over to the Duo and say, yeah, it's me. Go ahead and log me in. This will be bringing me to a screen where I can start some sessions on this machine. Don't bother saving the 1 that I pressed to get a Duo prompt. I don't have any sessions graphically running on the machine right now, which is number 10. And again, I could change this 10 to 11, and that would get me access to another machine. The CSCI Labs has a so-called shared file system, so irrespective of what lab machine I log into, the files that I see and have access to will be identical between machines. So pick a number that seems to work, and if you're logging in and not getting a response, or logging in and getting some permission or licensing errors, then just try a different machine by altering the URL up here, or over here clicking on a different machine. You can see most of the CSCI Labs machines in the different labs, Keller Hall 1250, Keller Hall 162, and Walter B28. These are all equipped with this FastX3, along with a variety of other machines that are part of the lab machines. I think you should favor the FastX3 connections. They're a little bit better, but there are some on an older FastX2, and that includes the Vole System, which are a series of virtual online machines. Anyway, I'm going to start a new session by pressing this little plus over here and fire up XFCE. The beautiful part about Linux is that they have a variety of different graphical environments that one can install. The kindly operators have installed a couple of them here. If you're sitting physically at the machines, you might be able to get access to a couple others, but I prefer XFCE. It's sort of a lower overhead desktop. Now, I've noticed in a few cases as I try to launch, sometimes I got a license error the first time, but I just have to keep clicking. So let me just try that one more time here to see if it works. If this goes too far south, we can try other things. And I know a moment ago I was logging into a different machine and got this to work, so we'll just try again here. It doesn't seem to be working, so let me try GNOME instead. This is a persistent problem that I've been meaning to talk to the operators about. I think it's just a latency issue where as you try to launch the desktop, it doesn't respond fast enough, and so the machine is angry about it. Okay, so in this case, I'm just going to say something's wrong with machine number 10. It might actually be down, and for reasons I don't entirely understand, you can get a connection like this to try to talk to it. That's fine. I tried machine number 37 a minute ago, and that worked out okay. I see no sessions here, so let me try again, and notice the URL up here, machine number 37. I'll try a launch here and see if I have any better luck. Oh man, you're killing me here. Wonder, let's see. No, I don't want to create any bookmarks. Okay, I'm going to pause this for just a second to see if we can resuscitate the machines. All right, that just took me a moment of trying in order to get a connection. In most cases, this should fire up right away, and I'm writing to the CSCI IT help staff to figure out why it's a little bit shaky in that respect. But now we are in. Now what I'm looking at here is the desktop on a different computer, CSCI Labs Keller Hall 1250, machine number 37. You could physically go sit down at this machine, and we'll look at a second if you're curious at commands to find out if anybody else is using this machine at the moment. But for right now, I can treat it more or less as my own. Importantly, I still want to, at some point, get the lab code on here, and that's probably going to be my first step. You notice I'm running in a web browser here. This happens to be Chrome, but I'm actually going to, on this remote computer, start a web browser there so that when I visit our labs page and download the code, it goes to this CSCI Labs system instead. Just remember, though, you can poke around. For instance, there's a home directory over here. I have a 2021 folder, which might not be a bad idea for all of you to create, along with a bunch of other folders here for crap that I've accumulated, including my little Zelda-themed desktop here for that remote computer. I'm going to fire up a web browser. Firefox seems to be the default. It's always angry about something like I didn't start it or close it or hold its hand or something like that. And I don't have any bookmarks here for our course page, but I happen to remember my own personal URL. So that's cs.umin.edu/tilde-kaufman. This is a typical convention where if you have some sort of a website and there are different users with their own personal web areas, it's usually tilde-kaufman for web home for folks. And then this will be under 2021. You can see that redirects just a little bit, but that brings me to the following index page, and I click through here to this course schedule and materials. Alternatively, you can also just from website, for instance here, copy this page, URL up here, this link, and then jump over here and paste it in, and I'll allow the pasting to happen here. So let's see, that goes something like that. Actually, I'll delete it and then paste it. It doesn't look quite right, so I'll just delete this part. Man, I am really screwing this one up here. So let me paste. That still doesn't look right. Oh, I know. I copied the whole thing before I got rid of it. I cut it. Okay, so I need to recopy this one and paste this one in, and now we're good to go. Okay, cool. All right, the whole point here was to grab this particular zip. As I click on it now, I'll be downloading, but this time instead of my personal laptop, this is going to go into the remote machine, Keller Halls 1250 number 37. I'm going to save that file. Don't bother with the archive manager. We'll show you how to unzip it in just a second. Irritatingly these days, when you download something with a browser like this, it doesn't actually ask you where you want to put it. It usually goes to some default location. So if I see over here, then usually there's like a show in folder option. And you can see I went to my home desktop. And so if I minimized all these windows here, go away, then you can see, sort of amidst all the stuff, there's my Lab01 code.zip. Now I'm going to maybe want a little bit of an organization here for this. So I think I'll launch a new browser. So here I'll right click and maybe make a new folder. Here, oh, not opening a new window. I will create a folder in here. It's good. It's desktop, create folder. There it is. Okay, cool. And let's call this CSCI 2021. And I'll maybe move my Lab01 zip in there. Okay, cool. Now at this point, it would be a good idea to open a terminal up where we can actually unpackage this thing. In a lot of cases, as you would deal with this in a GUI, I could double click and this would open a program that's designed to extract it. And I could do so here by punching the extract button. But I actually want to show that this idea of manipulating data like this is possible in a GUI, but it's also possible in a terminal. And in some cases, you may be restricted to terminal access only to machines. So it's a good idea to be aware of some of the quirks associated with it. Let me open that terminal up down here. And you can see I start out in my home directory. The ls command in a terminal like this will list the files that are in there. And you can see there's a bunch of stuff in here, a downloads directory, a documents directory, some Android stuff I was messing around with, and finally there's a desktop directory, which is where we want to head. So let me change to that desktop. If I list again, you can see there's a CSCI 2021 directory that I created. So I'll change to CSCI 2021 and do a listing here. And there's my Lab01 code.zip. In a lot of cases, there'll be an option, oftentimes if you right-click, to open a terminal here, which will open up a terminal right in this folder rather than having to navigate from your home directory, which is the default location. But this is sufficient for the moment. The command to know, then, to unzip files on the command line is just unzip.
And I'll pinch Lab01 code. Now I want to mention something quick that's a useful trick on Unix systems. I typed lab here. I'm going to press tab. And you can see the auto-completion feature of most shells will fill this entire inth for me because it's the only file that will complete the starts with lab and ends with whatever. Tab will complete that for me. As a punch enter, you'll see a bunch of information listed here about what the unzip program is doing. It's pulling out all the files and folders that are present in there. And you can see over here in the graphical display that a new folder is created. It's Lab01 code. It's listed with a different icon here rather than the zip icon. And if I do a listing over here, you can see it doesn't have the extension .zip. Now, I wouldn't necessarily know that it's a folder here except from experience or from looking like this, but this is the convention that will follow throughout the class that when you have a zip file like this, when you unzip it, it'll create a folder with the files in it that are named after the zip. Let me change in there into Lab01 code. Now notice two options came up at this point because it could mean the folder Lab01 code or the .zip file here as I press tab. I want the folder, doesn't have anything on it. I could type the slash, doesn't matter. And so I'll list in here and there's all those folders just to keep track at home. If I double click here, then you can see there's a bunch of stuff in here. The first thing I want to do in most cases is to open up this questions.txt file. I'm going to open up this with just the plain old text editor, which is the default. You can pick other more fancy text editors such as VS Code or Sublime Text, or if you're a Mascis, you can try Vim and VI. But the default text editor is sufficient to get the job done in this simple set of cases. So just take a second because in a lot of situations the text editor itself needs to load. Now I see it's open up over here. Oh, I minimized it and I'll bring it back. And over here, hopefully this font is big enough for folks to see. You can see is the contents of that file. There are a bunch of lab instructions here, which I'm to some extent going to ignore because I know what I'm doing, but in the event that you get lost, you can turn your attention back to this stuff to try to understand what's going on. Again, there's an advisement that you'll want to get set up with a program environment along with the URL for the setup guide over here. But to that end, I'll let you guys read on your own on that front. So a couple of things on this front. There's a set of quiz questions over here, and we might actually be able to answer a few of these. First quiz question, an extremely easy way to access lab machines remotely, described in the guide, is buying a second laptop. That seems pretty obviously bad. Connecting to machines in a web browser via FastX. Oh my God, that's what we're doing right now. So that seems like a plausible answer. Adding Linux system calls to emulation on the Windows, then absolutely not. Actually, there's no easy way to connect to a lab machine. Well, I mean, it took us about 5 minutes to set it up, so I think this is our most plausible answer for the moment. So I'm going to put a little X in here instead of the space. Now, in a moment, we're going to be able to check answers here, that whether or not this is correct. But in the event that we got anything wrong, it won't say which one is wrong, just say something in here is wrong on that front. But it's a good idea to sort of track along so far, and I think this is an easy one to answer out of the gate. There's a description of the Vole system down here. Now, Vole was an alternative that we didn't talk about a lot here, but similar to the graphical interface we have over here. You can click down here for Vole, CSCI.edu, and it will log you into a pool of online virtual machines. It provides a very similar interface to what we're getting here with this FastX3 connection, just uses a slightly older FastX2 version of that. And so I can rule out a few possibilities here. So website describes Unix commands, not so much. Web interface that gives you a graphical Unix environment without needing to install anything. Yep, that's about right. This one, terminal command that allows easy access to the UMNs. I actually don't know if Vole is a terminal command. Vole? Nope, not installed. Maybe you meant Vile. Nah, no, I did not. So that's not it. You know what a Vole is, Morty? Oh, I guess that's a cultural reference. And if you're curious about it, you can Google for it later after you finish the lab. Consider that your reward for finishing the lab. Let's see, and then another question about Vole. What's a common complaint about Vole? This is a complaint that you may get, or experience rather, with any of these FastX connections, that if you have a reasonably strong internet connection, it should work seamlessly, but occasionally, as you would type a key, for instance, S, it may stutter. And there's this little protocol that all computers use to communicate where it'll say, send a message to the remote computer from my laptop saying the S key has been pressed. And then when I release it, it'll send another little message saying the S key has been released. If there's a jitter in the network, then the receiving machine might get the has pressed the S key, and then a second later receive the released S key. And so it'll seem like you've held the S key for some time there, like a full second, which usually leads to repeated key strokes like this. Now we've noticed FastX3 is a little bit better in that respect, so probably not a big deal. So that's one thing, it lags sometimes. It is not exactly the opposite of a Mantis, so this seems plausible forward. It only provides a terminal interface. Not true, because what we're looking at here is graphical. I started a web browser. I have multiple windows opened. It doesn't give access to files they're stored in C. Well, we're looking at files right here, so the stutter business over here is fine. Lastly then, and this is a set of questions about the SSH tool that is installed on most systems. That includes Mac and Windows. This is a handy one to be aware of. And so if you open up a terminal on your personal machine, and I guess I'll do that here, change desktops over here and start a terminal by firing up in the middle here, there should be an SSH command, irrespective of what terminal you have. And nicely, this follows a convention that allows you to connect just in the terminal to another machine. So I can, for instance, SSH to the machine that we were just on. Let me copy that URL quick, because I don't feel like copying the whole thing or typing the whole thing in. Now, usually you want to prefix this with your X500, so that's Kaufman for me. I'm going to paste this in the terminal. Not all this stuff is relevant. In fact, we want to get rid of all this stuff right here. And then I'm going to back up because the HTTPS, that's short for Hypertext Transfer Protocol, and I'm actually not going to be talking this thing like a web browser. I'm going to be talking it through an SSH protocol instead. So this is the actual machine name then. And you'll see this in internet programming sometimes, the name of some computer to connect to. As I'd push enter now, since I've got this set up, I'll actually get a connection straight to it. In your case, you'll probably need to type in your password and do a duo verification. But if you're handy with SSH keys, you can actually figure out things, how to set this up without need for password prompt. There's a handy little command, a W, that allows you to say what's going on in this machine. And you can see I'm logged in, along with a few other folks that are over here. I'm slightly surprised that there aren't other, like, 2 mentions of me because I'm logged in graphically once and another time non-graphically. But at any rate, here we are in terms of I'm logged in here. I can see things. I could change to my desktop, find that 2021 file, so 2021, and change into that the Lab01 code and see all the stuffs here, including the questions.txt. In the event that you need to edit code in a terminal-only session, there's usually a very primitive but nice text editor that's terminal-based called Nano that's installed. So I could, for instance, open up Nano and then say, here's questions.txt, and this would fire up a little text editor in the terminal that I could do my editing. You can see over here I've got blanks for some of those things, but if I come over here and actually press the save button over here, I don't know if Nano refreshes or not. If I exit and start it up again, I should see, yeah, like for instance, here is one of the X's that I filled in. So this has your standard save and so forth, and then the commands that you probably need to know are down here, like Control X to exit this thing. But we'll eschew the terminal-only browser or terminal-only text editing for the moment. All right, so I'll let you guys experiment a little bit with solving the remainder of the questions. There are several others down here, including answering what this sequence of commands does, creating directory, changing into it, and so forth, and changing up. When you're done filling in the little multiple choice options over here for the quiz, there's some instructions down here about how to test whether or not your answers are correct. Now this makes use of a build automation tool called the Makefile system, or Make for short. And it's got a set of rules that are specified in text files that we can look at in a minute if we have time. But for the moment, it's sufficient just to know that you can check your answers by typing the command make test quiz. This will look at the contents of the text file here and check whether or not they match some expectation. I can do so now by saying make test quiz in the terminal. And this will notify me that there's something wrong with my quiz answers. And to that end, I'd want to make some corrections there, fill some other things in. You can see over here there's a warning and a failure, and I've gotten so far no credit for this thing. Let me just quickly fill in the rest of the answers, and we can, I think, be on our merry way here. So for instance, this SSH business opens secure connection. That's an X, and SCP copies stuff from one place to another, and it copies recursively, I think. So we can check that in a minute. I haven't actually read the full answer there, so I don't remember it. Down here, this should change to my home directory. That's a tilde. Creates a folder named CSCI 2021. That's good. Changes the directory to be your home folder. Nope, not that. Changes home. Creates a second folder, CSCI 21. Nope, not that one. Changes the creates a folder named CSCI 21. Changes into that. Change into here. Lists the files in that in the current folder, so there should be nothing, and then moves up one folder. Yeah, so this last answer is looking more plausible there. Okay, and I think that's it for the quiz question. So now that we've done that, and I will save this thing, I can rerun that little make test quiz. And hey, it looks good. All answers accounted for. So the quiz part is done, but we still have a code part to do, and that's described a little bit lower. That there is a source code file called helloc.c, and it's going to be our job in order to fix it up and create it. Now, it'd be a good idea just to run this thing to show what it does. Probably all of you will get the gist of it after not too much trouble. Since there's a list of commands here that will do it. If I, for instance, type just make, oops, I need there. Then you'll see that, maybe I'll do a make clean first and then a make. You'll see that this invokes a GCC command with a bunch of options, and a couple of them that are somewhat important. The source file to be compiled is this helloc.c, and the output, -o, named the output program, that's going to be called helloc. These other options over here are about warning of things like fishy and adding debug information, so forth. Not a big concern, but this would be a lot to type on my own, which is why it's really nice to have a make file that just will run this command anytime I type make. And that'll include if I make changes to the source code program, I just type make again, and it will rebuild the program. I can run this helloc program just by typing /helloc. And you can see it prints out a little poem, of which I'm very proud, so don't diss it. But it does have a few problems in it in terms of bad output. As in the output here, and there's no reason you need to know this out of the gate, but it's the point of the exercise is to modify this output so it matches some expected thing. And the expected output is part of the testing framework. We can do that. For instance, as mentioned out here, you can run the program. We can, similar to testing the quiz, test whether the code is conformant by typing make and then test-code. So here's make test-code. And at this point, I think it's worthwhile to make the terminal full-sized so that we can see more of this. I'm going to punch enter now. And you'll see over here that the terminal command that I invoked was way up here. And the first part of this output indicates that this was a failure. Expected failure because we haven't actually made any changes to the code yet. Throughout the course, you'll be running automated tests like this. And in the event of a failure, if you're running just a single test, then some output will be printed to the terminal. But also, if you are running multiple tests, then there'll be a mention of failures reported in little temporary files that we can open up in a text editor, and we'll do that in just a second. It's also a good idea for a single test like this. You can look just on the terminal itself to see over here what's going on. There's some description of what this test is doing. And it's super useful in the event that you're trying to diagnose the test yourself, that you actually read. This is what the comments say about what this test is doing. Beneath it is a description that what comes later is a side-by-side diff. There's a series of symbols that will appear between the expected and actual outputs, with the symbols taking on the meanings of there was more in the actual than in the expected. There was a line in the expected but not in the actual. Maybe I'm reversing those two. Or there's a similar line but they don't exactly match. That's what the little vertical line means. You can see that in spades down over here. That, for instance, the first symbol that I see between the expected output over here, what I want to happen, and the actual output, what my program actually produces, the first discrepancy is here at this little vertical line. All the lines that precede this are identical to each other, so I don't have to worry about those too much. And you can see the wrongness here is just a matter of the expected is au revoir, au camel, c'est la vie. I was corrected by one of my TAs that this is the proper French versus the homonym c'est is an incorrect grammar in French. So we'll just want to make some corrections to the program so it prints that instead. Over here is a similar discrepancy, expected 8 of which is a byte, and down here is a question mark, so we'll have to fill that in with an 8. And then over here is an output line that appears only in the actual output, but is missing in the expected output, so we'll just have to delete that one. And conversely, down here is a line that's in the expected output that's missing in the actual output, so I'll need to add that to my program. Before we get there too much, I think it's a good idea just to look here at this test results Lab01 test number 2 result.temp. And oftentimes this will come up, and we'll see this in a second. If you type make tests, this will tend to run all of the tests that are available. I can see over here, never mind. Up here, I ran the quiz tests, and those are okay. But then there's a listing here of, oh, this one failed. And so if I want some information about it, I can open up this temp file over here. Let me do that over here in my little file browser. You can see a new directory has been created, this test results. And here's that Lab01 result.temp. I'll just open it with a text editor, which is fine. You can see it's a replica here of what I saw in the terminal. In the event there's a lot of outputs, then it's easier to look at this usually in a text editor so that you can see it. If you happen to be an Emacs user, this is actually formatted in org format, so you can get slightly nicer output there, but no matter on that front. So the main thing is I'm going to be looking for in terms of my source code is to try to correct those errors that are mentioned over here. Over in my file browser, let me just have a look quick here. So I'll go back up a directory and find that hello.c.c program. And as I did before, I'll just open it up this in good old-fashioned text editor. gedit, which is the name of this plain default text editor, it has reasonably good support for C programming. So you can see out of the gate, it has syntax highlighting, putting these comments in blue, some keywords like pound include in different colors, and all these string constants that are part of what the program output is producing. They're in this light pink, which I'm sure is going to show up terribly in terms of the video that I'm making right now, but bear with me. I'm going to pause for just a moment to see if I can increase the font size a little bit to make this slightly readable. All right, so it just took me a moment to navigate through this little preferences and then find the fonts and make the font size a little bit bigger. So you can see that down here are all of the lines of text that the program is producing. They're declared in this little array of car pointers. And all that the program does is to iterate through this array, printing each string on its own line, and then terminating successfully. So literally all we have to do is to correct the errors that were identified in the output. This is about as simple as it gets in terms of fixing up programs, and you should expect passing tests will require writing a lot more code and debugging various things, but this one's essentially a gimme. So let me look back over at this results here. And I can see in my test results, the first thing I got wrong was this au revoir business. So let's make a change there. So that's supposed to be C'est la vie. I'm told it's actually pronounced C'est la vie. And that's French for such is life. So over here, I'm going to nix this and plop that down. Just to see if I've made any progress, let me punch the save over here. And then I'll click on my terminal here. And I will rerun that test code business. And you can see, yeah, good. So the little line that appeared between these two has disappeared, indicating that the lines now match. So we're down one error and just have a few more to go. In that respect, I'll come back over to the little C. And look here, now it's time to bang on bits, blank of which is a byte. Well, by now, if you've been attending a lecture, you should know that's 8 bits in a byte. Wait, does that even make sense? I believe that was a line we were attempting to eliminate. It appears over here, but does not appear in the output here, or the expected output. So let me grab this stuff and nix that. So let's print a blank line there. And then we're missing a line here and there's sort of an obvious gap of like, okay, what's supposed to be there? So let me grab over here from this text file the expected output, which is this, and stay the course business. I'll just Control C to copy that, and then Control V over here. Maybe put some spaces in to get it lined up right, and then Control V. I'll put a comma to follow the comma separated values in an array like this. Give it a save, and then jump back over to the terminal. Make test code, and ooh, so nice. Okay, so all tests pass at this point. So let me do a make test in order to verify that both tests are still passing. You can see all's well, and that result 1 out of 1 is something that I'll expect will show up on Gradescope when I upload this code. At this stage, I'm feeling pretty good about the lab, so I'm ready to submit. To do so, I have to create another zip, and there's a build automation process for that. It's another make invocation. In most cases, as you'd want to know, well, what can I do with this make system, at least for the make files that will provide you in this class, you can type make help. And this will give a quick reminder of what's possible to do in here. Test the quiz, test the code, clean up all your files, or in this case, what I want to do is to create a zip file for submission. I'll type make zip. You can see that has run a series of commands and created a lab01 code.zip in this directory. Let's just check over here in the file. I can see a lab01 code.zip. Now, one thing I want to warn folks about, that this is actually in the lab1 code directory. If I go up one directory from here, you'll see here's my lab1 code directory, and here's the zip file that originally downloaded that has the blank copy of the lab in it. None of my answers, none of my code modifications, etc. At this stage, I start getting nervous about there are two lab01 codes.zip. I don't actually want to submit the empty one because that's going to give me no credit. So I'm actually going to get rid of this old one that was a copy of that. And now I'm down to one over here. We should be good now to log in and submit to Gradescope. So if we're looking at that, not this Firefox thing, I wanted to come over to the existing Firefox, which is here. If you click on Gradescope over here, you'll log in and then find a spot where it says upload for your 2021 class, the Lab1 code. At that point, as you click, you'll see a little bit of business to sort of upload there. Oh, actually, I have pictures for this. They're a little bit lower down here. So you'd click on Lab1 to submit, and then take that lab1 code.zip file, select it as part of the file selection process. It'll mention over here, by here are the files, upload them, and then wait a few minutes. If you see a result like this, that you're locally getting 1 out of 1, but
Gradescope is reporting you're getting 0 out of 1, then something's gone wrong. Try again or contact staff. But in most cases, if you're getting locally things, then you'll see the 1 out of 1. In the event that you're working in a group, and this goes for any of the subsequent labs as well, then make sure after uploading to add group members. There's a little button here to push to add a group member, and as you would enter names down here, it should auto-complete to someone else that's in the class that you may have worked with. All right, that takes us through to the end of this lab walkthrough. I hope you have found it helpful. And if not, post some follow-ups, ask some questions on Piazza, and we'll try to sort you out. From time to time, try to post some videos about this. Next one planned is a debugging video of some sort to help you once you actually get some appreciable C code to navigate how to interpret messages from the memory checker like Valgrind, possibly how to sort of step through in GDB, although that's a topic we'll spend quite a bit of time on later in the class. At any rate, look forward to that one coming up next week sometime. Take all, and happy hacking. I'll see you in lecture.